Good day, guys. We are now looking at another problem on partial fractions. And as I always tell you, when you pick partial fractions, compare the degree of the numerator to denominator to see whether the unit long division. So from here, that is a 2. If I go to the denominator and expand everything, you see it will be x cubed, and 2 is smaller than 3. That means this is a proper fraction. And with proper fractions, we don't need any long division. So we're going to go straight to our partial fractions. So I get 2x minus 1 all that cube. So my partial fractions will simply be a over 2x minus 1 plus b on 2x again minus 1 squared plus c on 2x minus 1 cube. So for N6 students, you can check page 6 of your formula sheet. There is a formula that helps you with this when your denominator is factorized completely to get one linear term that is repeating 3 times. That's how you write your partial fractions. Then you can now start the procedure of looking for a, b, and c. So our LCD will be 2x minus 1 cube. If you divide itself, you get 1. You multiply to the numerator, you get 12x squared minus 10x minus 2 equal to. If you take this and divide there, 2x minus 1 will reduce that to 2. So this will be a into 2x minus 1 squared. Then plus, if you take this and divide there, 2x minus 1 squared will reduce that to 1. So we get b into 2x minus 1. Then this is exactly like that. So we're left with c there. So at this stage, to get a, b, and c, we can still choose 3 numbers. But the best option for me, the fastest option when I discovered I'm solving a problem where the denominator is factorized to a single linear factor repeating 2, 3, or 4 times, I prefer to expand. That is faster for me, which I would suggest you also do that. So to expand the left hand side does not need any expansion. On the right, this is basically the only thing you are expanding, which will give us a into 4x squared minus 4x plus 1. I always explain to my students that the best way to expand this, it's not by taking 2x minus 1 into 2x minus 1. That is okay. If you can do that, it's okay. For me, that's for high school students, but for tertiary students, you just take 2x, you square it, you create your 4x squared. You take negative 1, you square it, it will give you positive 1. Then the middle term is always 2 times negative 1 times 2x, which takes you to the middle. So it's the same thing like taking your time to expand that. If you know simple techniques like that, it always helps you move fast. So we can now compare coefficient. So the coefficient of x squared, on the left, I see a 12. On the right, I see 4a, which tells me that a is equal to 3. That is, if you take 12 divided by 4, it's a 3. Then I go to the coefficient of x. On the left, I see a negative 10. On the right, I see a negative 4a plus 2b. Those are the coefficients of x. But you see, we already know a to be 3. So 3 times negative 4 will give us negative 12 plus 2b. So b will, negative 12 will go there as positive. So you have 2 is equal to 2b. And all of this is simply telling us that b is equal to 1 if you divide both sides by 2. Then finally, the constant term on both sides. On the left, our constant is a negative 2. On the right, we've got an a, we've got negative b, and we've got a c. What is a? We've got a as a 3, we've got b as a 1, and a c equal to negative 2. So 3 minus 1 is a 2. So 2 will go that side as negative 2. So negative 2 minus 2 will tell me that c is equal to negative 4. So we have succeeded to get the values of a, b, and c. So it's now time to do integration. We must now remember that this integral of this fraction will be replaced by 3 of those, the 3 partial fractions that represent bubble. So my integral of 12x squared minus 10x minus 2 on 2x minus 1 ordered cube will be replaced by our a is a constant. So I'll capture this, where a, b, and c are constant. I keep saying, practice saying all your constants outside. So this is 1 on 2x minus 1 dx. Then our b is a positive 1. So we get plus the integral of 1 on 2x minus 1 all that square dx. While our c is a negative 4, that's a constant. We get 1 on 2x minus 1 all the cube dx. So if I can do those 3 integrals, then I'm sorted. So these 3 integrals, they all need u substitution. And for an in-6 student, there are formulas on your formula sheet that will help you navigate through u substitution. So the first one is the u substitution for a fraction. So if you look at that, rather than wasting your energy saying let u be 2x minus 1, you look for the u dx and do all those things, you can just try to manipulate, to readjust this to accept that formula. So for it to accept, what you see at the denominator, its derivative must be at the numerator. So when you look at this, 2x minus 1, its derivative is 2, not 1. So I have to take another step where I will do such an adjustment. So if I go there, I will get to just copy my 2x minus 1, put it there, as the formula says. I'm trying to do what the formula says, then I differentiate it. If I differentiate 2x minus 1, I put at the numerator. That is what the formula says, but I must be careful that what I've written here is not different from the original problem. So if you look at it, you see that it's different because 2 is not equal to 1. But now, how can I make sure that what I've written here, which is what the formula says, still matches the original problem? I just get a number that can take care of these 2 and take it outside. So outside, if I put 1 over 2, it means that if this takes care of that, I go back to the problem. And at this stage, it means in my problem, I now have 3 over 2 outside, and also at the same time, my problem accepts the formula for u substitution, and I can then write my answer as the as 3 over 2, the ln of 3 2x minus 1. So that's how I've adjusted that one. Now the last 2, they are using the same formula. It's also a formula for u substitution, which my N6 student, we are used to calling it the power rule. So when I see a function that is written with a power, I immediately know that I'm going for the power rule. So it's u substitution for multiplication. So I have to just readjust my problem to look like this formula, which is also on page 4 of their formula sheet. So what do I do to adjust this to look like this? I just need to move the 2x minus 1 up. So this will be plus 2x minus 1. Then the new power will be negative 2. So you see this part matches that one very well. What is left is the derivative. So I need the derivative of 2x minus 1. That will give me a 2 dx. So when I compare it to the original problem, you see that 2x minus 1 to the power negative 2 matches this part. So this 2 is not there. So to make sure that the 2 are still the same, I need a number outside that can cancel the 2 or can balance out the 2. And that must be 1 over 2. So now this term is ready for this, and I can use this to write the answer. And the beauty of this formula is that if you look at these 2 terms, the only difference is the 2 and the 3. So whatever adjustment I did here, I'll just copy and paste here, and then change negative 2 to negative 3. So if I go here, I'm no longer thinking, I'll write my 4, multiply by 1 over 2, that 1 over 2, the integral of 2x minus 1, to the power, negative 2 now become negative 3, then I multiply by 2 dx. So it means I've done u substitution for all my 3 problems, and now I can write down my final answers. For the first one, I'm using the first formula. So anything outside is a constant, you must be seeing your final answer. Then here, the derivative of 2x is a 2, matches the formula. So if I use the right hand side, I get the ln of 2x minus 1 Then for this one, I have my constant out. Then the last tool, I use the last formula. I just need to make sure that f of x, the power increases by 1. My f of x is 2x minus 1. If you add 1 to it, I'll get 2x minus 1 to the power negative 1 divided by negative 1. Then this side, I get negative 2. I do the same thing. The power will increase by 1. 2x minus 1 to the power negative 2 divided by negative 2 plus c. So if you now simplify your answer there, you will see that you have arrived. The half divided by negative 1 is negative 1 over 2 into 2x minus 1. Then negative 2 divided by negative 2 is positive 1. 1 divided by 2x minus 1. I'm now trying to make sure my exponents are positive. So guys, that's how I solve the partial fraction. Thank you very much.